circle has one, so let's try to draw what they're describing. Has only one X-intercept. Well, clearly it can't be anything like that. How can it only have one X-intercept? What does it have to do?
It has to be a tangent of the X.
Yeah, and it has two Y-intercepts. So something like that would work. It would certainly satisfy those two requirements. And a radius of 2. The coordinates of the centers are integers. Okay. Draw the X and Y axis on the grid below to show a possible graph of the circle. Add numbers to each axis. So what could a possible center be? Has to be integers. What's the y-axis have to be of the center?
It has to be 3.
The radius of the circle is 2, and the circle is 2 to the x-axis.
There has to be 2 y-intercepts though.
Right, but the y-intercept has to be 2. Why? Because all radiuses of a circle are equal. That means that dimension has to be 2. In other words, the most important thing we know is that it has only one x-intercept. That puts the y-coordinate at 2. You see why? The x-coordinate, well, how about if we made it 1? Now, that means the center is only 1 away from the y-axis. Remember, this is the x-coordinate of 1. This is the y-coordinate of 2. You see how the radius is 2? Okay, and you see how it's got to be tangent to the x-axis. And by making the x-coordinate 1, it couldn't make the x-coordinate 2 because then it would have been tangent to the y-axis also. And it wouldn't have 2 y-intercepts. So I had to make the x-coordinate either 1 or 0 or -1, one of those 3 integers. But the picture that I have drawn satisfies all of their requirements. What's the equation of the graph that we just drew? Start with the general formula. Give me the general formula of a circle.
H plus minus, no, x minus h.
It's always x minus h until you get to calculus.
Plus y minus k squared equals r squared.
Yeah. All right, well, we have h, we have k, and we have r. So what's the equation of the circle that I drew?
X minus 1 squared plus y minus 2 squared equals 4. Or 2, 4, yeah.
Yeah. Just like that. And like I said, there were actually 3 options, but only 3. Y has to be 2 because the circle is tangent to the x-axis. X can't be 2 because that would make it tangent to the y-axis. But x could be 1, x could be 0, and x could be minus 1. any of those values would give you 2 y-intercepts and 1 x-intercept, and a radius of 2. What else we got here? Let's see, hold on. Figure out the coordinates. Coordinates has a hyphen in it? I didn't know that. Figure out the coordinates of any x-intercepts and y-intercepts for the graph x minus 4 plus y squared equals 36. X minus 4 plus y squared equals 36. All right, let's graph it. First of all, where do I start?
Y is 0, so we start at 4, 0.
Okay. That's the center of the circle. What's the radius?
6.
Okay, so one part of the circle is going to be about right there at 6, 0. The other part's going to be over here at -2. Let me draw it a little better. -2, 0. So my circle should look something like this. My scale is a little off here. Let me change the x-coordinate. I'm going to still leave it at 4, 0, but I'm going to make it look like, what did I do wrong? What's this coordinate right here? If I have a radius of 6, what is this coordinate? It's not that.
10.
Correct. This coordinate over here is correct. In other words, this is a radius of 6. Now, it said, hold on. Find out the coordinates of any x-intercepts and y-intercepts for that graph. Okay. So we need the x-intercepts, we need the y-intercepts, and we need what they are. Oh, we got both x-intercepts, right?
Mm-hmm.
So what we really need are the 2 y-intercepts. Right there and right there. How do we get y-intercepts? We get x-intercepts by setting y equal to 0, right? In other words, whenever we're on the x-axis, y is 0 by definition. There and there. Well, how do we get y-intercepts?
By setting the x to 0?
Yeah. So, let's set x equal to 0 and solve this equation. So you have 16 plus y squared equals 36. That means y squared equals 20. Y equals plus or minus root 20. And notice both the plus and the minus are going to play here. In other words, we got a plus and we got a minus. But simplify that. What's root 20 equal to?
4.47.
No, that's not what I meant. In other words, at this point in geometry, you're never going to do that again. All your answers need to be in terms of radicals or pi. You don't convert to decimals.
2 square root 5.
Yeah, that's a precise answer. The decimal you gave me is not. So, what's this coordinate up here and this one down here?
Uh, 0 plus or minus, or plus
this
2.
one is the plus.
Yeah.
The negative is this one down here. That's why I said both of them are going to count. And I believe that answers their full question. Do we have more on this page?
No, but I have a question because I just took the test for this.
Okay.
When it has like, so say it says x squared plus y squared plus 6x plus 5y minus 20, I think it was, equals 0. Yeah, how do I put it into standard form?
All right. Standard form is this, correct?
Yeah.
So I have to combine the x terms, complete the square, combine the y terms, complete the square, and that will solve it. And here's what I mean. I'm going to put the x terms together, and I'm going to leave room to complete the square. I know I'm going to have to complete the square on all conic sections because they're all in this format. And that format is a linear term squared. Whenever your format is a linear term squared, you're going to have to complete the square on it. Put the y's together similarly, and put the number on the other side. Now notice how much closer we are to standard format. Now let's complete the square. Complete the square on the x terms.
Minus 6x.
No, completing the square is pretty simple. Just take half this coefficient and square it and add it. Always add it.
Half, so 3, 9.
Since I just added 9 to the left side, I got to add 9 to the right side. And the key here is to make sure you don't ever change anything. In other words, is this the same as this? Yes, it is. I haven't done anything. I've just rearranged everything. I combined the x terms. I added 9 to the left. I added 9 to the right. Same equation. Now let's complete the square on the y term. What do I have to add here?
6.25.
Since I added it to the left, I got to add it to the right. And now the reason this works is that because I completed the square, I can write that as a linear term squared. What is it? What's the linear term? X what? Something squared.
X plus...
Whatever you got when you took half of that middle coefficient. You got 3, remember?
Mm-hmm.
Okay, well, if you square x plus 3, you get x squared plus 6x plus 9. That's the key. These things are the same. The difference is that I'm getting closer and closer to standard format. How would I write the y term?
Y plus 2.5 squared.
And the right side of this equation looks like 35.25. So now, where's the center of this circle?
-3, -2.5.
And what's its radius?
5.93.
Just the square root of that. Again, I'd rather you not give it to me as a decimal. It's not as accurate. Not unless it was a perfect square. If this number is a perfect square, then I take it back. But I don't know that it is. Let's see, 4, that's 140 fourths. 141 fourths? No, it's not a perfect square. So this is the best answer. Square root of 35.25. Excuse me. We want the square root of 35.25 is the radius. But in the standard format, it's r squared. So the formula for this circle is actually that. In other words, what I have on the bottom row here. Because it's equal to r squared. And this is r squared. If they ask for the radius, then we need to take the square root of this number. But if they want just the formula for the circle, this is the proper formula. Now, let me just review one thing with you. Especially since you're in honors, you're liable to have this kind of a problem. Let's say there was a 2 and that was an 8.
Okay.
Complete the square on the left.
Would you do 4 times 2?
No. What you have to do, the very first step, is to make sure the coefficient of the squared term is 1. And you do that by factoring out that 2. In other words, there's the same thing, right?
Mm-hmm.
Okay, now if I complete the square, I take half of 4, it's 2, I square it, so I write 4 there. But what did I just add to the left side of the equation that I have to add to the right?
4.
No,
No, 6.
8. Because that 4 is being multiplied by this 2. So to balance the right side, now that's the same. In other words, this equation is exactly the same as that equation. That's the key with all of these, is make sure you never change it when you're completing the square. It's not a question of changing the equation, it's a question of rearranging it so that you have a linear term squared plus another linear term squared equals r squared. That's what you always want. Now, this is just an example. That wouldn't be a circle anymore. It would be an ellipse. But in terms of completing the square, let's talk just about that, because this is where it gets a little difficult. Let's complete in other words, this is a quadratic, right? 3x squared plus 5x minus 10. Let's solve it by completing the square instead of using the quadratic formula.
Can't you not complete that because there's not a 3 in both 3 and 5?
We still can do it. That's why I gave it to you, is because it doesn't have to be whole numbers. I'm going to factor this 3 out. Well, when you factor a 3 out, all you do is divide both terms by 3. That's the same, is it not?
Mm-hmm.
Okay. Now let's take half of this, 5/6, and square it. Becomes 25/36.
Wait, that's a 3, so it should be 25/9.
No, I'm taking half of this. Half of 5/3 is 5/6.
Yeah.
Okay, then when I square it, it becomes 25/36. So how much did I just add? The moment I wrote that into this equation, I just added a certain amount to the left side. I've got to add the same amount to the right side. What is it? What's the amount?
5/6.
Now, this number here is being multiplied by 3.
Times 3.
So it's 75/36. Now, I can write that as a linear term. That's the whole purpose, remember, is to write this as a linear term squared. And then whatever this right side is, it is. I didn't bother to do the math. I guess the right side is 12 and a 12. Okay? And now I can actually solve this quadratic by dividing both sides by 3, taking the square root of both sides, and then subtracting 5/6 from both sides. In other words, the way the quadratic formula was derived was by completing the square. If you take this and you do exactly what we did in that example, I move the c to the other side, I factor out the a, I take half of this coefficient, square it, add it to the left side and the right side, go through all of the math, you end up with x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. In other words, this was derived by completing the square of that exact formula, the standard formula for a quadratic. So completing the square is pretty cool because it allows you to solve quadratics that you normally would have to stick into the quadratic formula. In other words, had I given this to you as 3x squared plus 5x minus 10 equals 0, you would not have been able to factor it, so you would have had to go to the quadratic formula. Well, not really. There is one other way to solve it, and that's by completing the square. But that's not where you use completing the square. You use it in conic sections. You use it a lot in conic sections because all conic sections are given to you as some polynomial usually. In other words, they're not always going to give you a circle in perfect circle format or an ellipse in perfect ellipse format. They're going to give it to you as a straight polynomial like that. So you always have to complete the square in order to put it into its proper format for that particular conic section. Not always a circle. In fact, if I stick a 2 in front of the x, that makes it an ellipse right there. If I put a negative sign in front of the y, that makes it a hyperbola. All right. Wait, I got a 4 o'clock, so I got to run, but this is good stuff. I hope you, completing the square is one of the more important things you can do in math, in terms of the abilities. You definitely always want to know how to complete the square.
Okay, well, thank you.
All right. Talk to you next time.
Bye-bye.